7.4, guys, we're going to be talking today and tomorrow. 7.5 is the same thing, just some of them are a little more involved. But we're going to be solving trig equations. Every single person in here knows how to solve equations. No problem. If I said to you to solve this, could you guys solve that, what I just wrote in red?
Yes.
What would you do?
Add 1.
Divide by 2, right? That's exactly what you're doing in 2 sine theta minus 1 equals 0. You're going to isolate the trig function. You're just going to pretend like that's your x, so you get it by itself. So this would say sine theta equals 1/2. Now you're like, well, what does that mean? Well, think about it. We've learned something else about our trig functions. We're talking only right now about stuff on the unit circle. I'm going to give you a unit circle so you have something to refer to. But sine is what value? If you have an ordered pair, hang on one second. Sine is what? Sine is the y value. So what you guys would do in this case is you would go to your unit circle and you'd find all the ordered pairs where y was positive 1/2. Does that make sense? Yeah? Okay, hang on one second. All right, does everybody understand? We're going to talk about an equation like this tomorrow. It's called multiple angles. It's one little extra step. But it's nothing, guys. I promise, nothing that you have not learned before. We're just taking bits of this and bits of this and bits of this and putting it all together at one time. What is super duper important, which you should write down right this second, is what I'm about to write down right now, which again, we already know. We're talking about angles that are on the unit circle. So they're going to have an ordered pair. They're going to have an x value and a y value. Right? So if we're talking about the sine of theta, in my ordered pair, which is sine? Sine is your y value, okay? So write that down, y value. And we can consider this y over 1, right? Because it's, right? Anything that you don't see a denominator, it's considered 1, okay? All right, so now if we talk about cosine. Cosine is what? X. It's your x value. So remember, that's x over 1, right? And then what's tangent? Y over x. You take the y, put it over the x. Everybody with me? So our reciprocal functions, what does reciprocal mean?
Opposite.
Opposite, or you flip it. So reciprocal cosecant of theta, instead of y, it'd be what? No. Flip it. 1 over y, he said, yeah. So secant theta would be what? 1 over x, good. And then our cotangent of theta would be x over y. Okay, good. Okay, we good? Again, this isn't new. We've gone over this 20,000 times. So let's move along. Here's how we would approach these problems. This is what you guys should be. You should attack each problem with the same kind of thinking. All right, I know that proving and all that was hard. I know you guys had difficulties with it. I understand that. But we can kind of have a game plan when we go into solving an equation. The first thing you should do is you should say, okay, let me isolate my trig function. That means I want to get it all by itself. So I have sine theta equals 1/2. So think about this. Is there anything that's being added, subtracted, divided, anything with our sine theta? No, it's completely isolated, right? So now is the step you can say, okay, well, sine. What values are they talking about when they talk about sine? The y value, all right? Now, again, we're going to give you the unit circle. So what you're going to do in order to solve, we're going to answer in radians, right? We're not going to give degree angle measurements. We're going to be in radians. But we're going to look at our unit circle, which is right here, and find all of the y values that are positive 1/2. Take your time when you do this. If you notice, the unit circle is very similar all the way around. It's just full of a bunch of patterns. So it's really easy for your eyes to look in the wrong spot. You want to find where the y values are positive 1/2. Everybody with me? Do you see the two angles that I circled? All right, so your answer here would be x equals, and what are the two angles that we just circled in radians? 5 pi over 6 and? Very good. No, you're okay. I knew you were going to ask that question. What do you notice about both denominators? Both the same, both the 6. Okay, good. That's a good thing to look at. Very good thing to look at. Again, we're just introing. Everybody okay? Yes, ma'am.
I thought
It is.
So then what is the x, like where does the x equals come from?
Oh, it was theta equals. That's just your answer is all I'm saying. I'm sorry. Yeah.
Wait, why'd you pick that one?
Because I went to my ordered pair and I looked for where y values were positive 1/2. And it happens to be there and there. If it was negative 1/2, then we would look for negative, right? If this question said, what's the cosine's 1/2? You would look where? X value is positive.
Oh, and, okay.
Yeah. Sorry, that's it. Yes. All right, let's look at the next one. First thing I'm going to do, I'm going to isolate my trig function. We're going to isolate our trig function. Is my trig function isolated? Yes. So now I'm going to think to myself, okay, what is tangent? Tangent's what over what? Tangent is y over x. Okay, tangent's a little different. We're going to talk about it. Tangent is y over x. Can you just look at your unit circle and tell where you would take the y value, put it over the x value, and get a specific number? Hopefully you'll get to the point where you can. But let's talk about the unit circle just for a second here. I'm going to look at the first quadrant. All right? Everybody understand this is my first quadrant, yes? Okay. Now, if you notice all the other quadrants, and we've talked about this before, but everything on your unit circle is a pattern. Notice you don't have any random 3s or 7s or anything like that. Everything has a relationship. We have 1/2 square root of 2 over 2, square root of 3 over 2. It's all proportion due to the radian length on our unit circle. We've gone through this. Now look at, if I was going to find the tangent, let's find the tangent at everything in the first quadrant and our quadrant angles. If I looked at tangent of 0 or 2 pi, remind me again about how you would find tangent. What over what?
X over y.
Tangent, y over x. So I take the y value, which is 0, and put it over x. What's the tangent here? 0, correct. Let's come up here to pi over 2. What over what? 1 over 0. What's the answer to that? Undefined. Very good. Okay. Good job, good job. All right, now let's look at our ordered pairs in here. What is the tangent right here at pi over 4? You guys should be able to look at that and tell me. It's y over x. What's the y value? Square root of 2 over 2. What's the x value? Same thing. So when you divide something by itself, what does it equal? 1. You guys see that? So I came over here in the second quadrant and I said to you guys, well, what's the tangent at 3 pi over 4? Look at it. Tell me what the tangent is at 3 pi over 4. Why is it negative 1? Because one part of my coordinate is negative, one's positive. What is the tangent, guys, at 5 pi over 4? Positive 1, because a negative divided by a negative is a positive. What is the tangent at 7 pi over 4? Negative 1. Y'all see that? Yes? Okay, so let's look over here. Let's find the tangent. Let's find the tangent here when my x value is positive 1/2. Well, how would we figure this out? Square root 3 over 2, good. So square root of 3 over 2 divided by 1/2, correct? I have a fraction divided by fraction, so we keep change flip. What happens to my 2's? They cancel out. So the tangent here is the square root of 3. Agreed? So over here in the second quadrant, when my x value is negative 1/2, what's the tangent? Negative square root of 3. Perfect. If I come down here in the third quadrant, where my x value is negative 1/2 and my y value is negative root 3 over 2, what's my tangent? Positive square root of 3. Do you guys see the pattern all the way around? Your ordered pairs don't change. The only thing that changes are the signs. It is not the utmost important that you guys memorize this. It just makes things easier for you. Here, what's my tangent? What's my tangent here when the square root of 3 over 2 is your x value? It's 1/2 divided by the square root of 3 over 2. What do we do? Keep, change, flip. So my 2's cancel. I have 1 over the square root of 3. Is that allowed? So it's the square root of 3 over 3. If you guys could remember the first quadrant, it makes life easier for you in order to answer these questions. Because right away, we found the tangents in the first quadrant, right? Are there any other numbers that could be tangents on the unit circle? Do any of the ordered pairs change? They all stay the same, right? The only thing that can change with this is the signs, whether they're positive or negative. So when you get a question like where on the unit circle will you get tangent is 2, is there anywhere on the unit circle where your tangent is going to be 2? No, your answer here would be no solution or none. The reason why, you can do this with a calculator, but we're not using calculators. We're using just the unit circle. So it's helpful to know, and this isn't much to memorize, guys. Anything divided by itself is 1, so that should be easy. And then when 1/2 is the x-coordinate, your tangent's root 3. When root 3 over 2 is the x-coordinate, your tangent's root 3 over 3. You can think about it when your square root of 3 is in the x-coordinate, then the square root of 3 over 3 is your tangent, however you want to think about it. Just saying it's helpful. Because if you go to a question, let's do the next two. Change A to cosine and a plus. So we'll say A is 2 cosine theta plus 1, only because I did an example like this already. All right, so the first thing I told you guys to do, what's the most important thing to do? Isolate your trig function. So get that all by itself. All right, so what do? Subtract 1, agreed. So 2 cosine theta equals -1. Then what? Divide by 2. So I have not answered my question yet, but I'm close. I need to know the angles that we're referring to. So I'm going to look where on my unit circle? What's cosine? X values, good. I'm going to look on my x values, the x part of my ordered pairs that are -1/2. Go over to your unit circle. Where is x? -1/2. 2 pi over 3 and 4 pi over 3. Perfect. 2 pi over 3 and 4 pi over 3. What do you notice about your denominators of both of those fractions? They're both the same. Make sure you guys are aware of that. All right, so the second example, B, let's do B. It says tangent squared of theta minus 3 equals 0. Well, I want to get my trig function all by itself. So what do? Add 3 to both sides. So tangent squared theta equals 3. Take the square root. Perfect. You take this. If this said x squared equals 3, you guys would say, oh, take the square root. And then what goes in front of your answer? Right, but what goes in front of the square root? A plus or minus. Same thing. Square root, square root. So I'm looking on the unit circle where the tangent of theta is plus or minus the square root of 3. This is why it's helpful to memorize what I just showed you. So you don't now have to go, oh, geez, which ordered pair was it that gives me the positive and the negative root 3? It's just easier if you know, oh, what ordered pair gives me tangent is square root of 3. What comes first, the 1/2 in the x or the square root of 3 over 2? 1/2 comma square root of 3 over 2. I just did that on the last slide, guys. That's what I just did in the first quadrant. So anywhere on your unit circle where you have x value is 1/2 and your y value is the square root of 3 over 2, it'll give you root 3 as a tangent. I want positive and negative. So how many answers do I want here? Nope. There's 2 places that'll give you positive, and there's 2 places that'll give you negative. So how many do I want? I want 4. I want all 4 of them. So you want all 4 ordered pairs that give you Square root of 3 over 2, square root of 3, whether it's square root of 3 or negative square root of 3. So which one is it? Pi over 3, what else?
1 pi over 6.
You want 1/2 to be first, so pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. You see that? So your theta would be, we said pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3, right? I'm glad you said that, Joseph. Joseph said pi over 3 and then something over 6. What did I tell you? What should you guys notice about your denominators? They should be the same, all right? Depending upon which ordered pair, they should be the same. So just pay attention to that. If they wanted just the positive ones, you would find just where it's positive. If they wanted just the negative, just where it's negative. But you guys will be given you'll be given the unit circle. You know what over what. I just think it's a good idea to memorize what I showed you in that first quadrant about tangents. Moving along, you guys are like, oh, we finally started to kind of get it, and then you throw something like this, all right? Well, let's look at this. Before you get mad at me, let's look at it. I told you guys to isolate your trig functions, correct? So let's look at our trig functions. First of all, how many do you see? There's 2. What do you notice about those 2? They're the same. Good. One of them's what? Squared. I told you at the beginning of the year, right, that there was something in math that's never, ever, ever going away. What was that? Factoring. How many terms do you see here, guys? 3. Terms are separated by plus and minus sign. If I said to you, could you guys figure this one out for me? Every single person in here would be like, oh yeah, you multiply 2 times 3, you get 6. Find out what multiplies gives you 6, adds give you -7, right? This is the exact same thing. We did this with our exponentials. Remember we had like e to the 2x and e to the x. We had to factor it. Same exact thing. I'm going to break this up into 2 binomials. Instead of x's in front of my parentheses, what do you think I'm going to write? Cosine. Perfect. I have cosine theta here and a cosine theta here. Because cosine times cosine equals cosine squared. Now, what are the values that will multiply to give me a positive 6, but add to give me a -7? -1, -6. Good. Same rules apply. Since my a term is not 1, what do? You put the 2 underneath both of them. Everybody with me? Okay. 1 over 2 doesn't divide pretty, so this becomes 2 cosine theta minus 1. 6 divides by 2, nice and pretty, so this becomes cosine theta minus 3 equals 0. Now we're solving, so what do I do to each piece? I set it equal to 0, so I have 2 cosine theta minus 1 equals 0, and then I have cosine theta minus 3 equals 0. Okay, easy enough. Isolate your trig function, guys. So what am I going to do? I'm going to add 1 to both sides, and then what? Divide by 2. Good. So I have cosine theta equals 1/2. What is cosine again? X values. So I'm going to my unit circle, and I'm finding all the x values that are what? Positive 1/2. So go over here. So x, this is x positive 1/2. And this is x positive 1/2, right? So what are they? Pi over 3 and? There you go. Pi over 3 and 5 pi over 3. We good? Okay, so scoot along over here. Again, I want to get my trig function by itself, so we add 3 to both sides, right? So cosine theta equals 3. Cosine's what value again? X value. Where on the unit circle are your x values ever positive 3? Nothing. So what do? Cross it out. Very limited answers you guys can have. 1/2, root 3 over 2, 1, 0, 12, no. 7, no. 3, no. Right? All right, let's do the last one. You guys are doing a great job. We're almost done. Here we go. Here she goes again. Okay. Let's isolate our trig functions. Let's talk about what we see. How many terms do you guys have here? We only have 2, right? What do you notice? Is there anything squared?
No.
No? Okay.
Sine, cosine.
I have a sine, cosine, and then a what? Just a cosine, right? Do they have anything in common?
Cosine.
Huh? When you guys have something in common, what can you do?
Cross it.
You can't just cross it out.
Square.
No. What if I had 4x squared minus 3x? What do they both have in common? An x. We take it out in front, right? Same exact thing. I'm going to bring a cosine theta out in front. So when I do that, we're just factoring out a cosine theta. What am I left with on the left-hand side here? What am I left with? 5 sine theta, right? Plus what?
4.
That's it. What do you do with each piece now that you factored? Set it equal to. So cosine theta equals 0. 5 times the sine of theta plus 4 equals 0. Well, what's cosine on the left-hand side here? X values. Can you guys look on your unit circle, please, and tell me where your X values are 0? What are they?
Pi over 2.
Pi over 2 and? Perfect. So I have pi over 2 and 3 pi over 2. Great job. Now I come over here. Different trig function, but same thing. Sine is our y value. So I want to get my trig function by itself. I'm going to subtract 4, right? 5 sine theta equals negative 4. Divide by 5. So I have sine theta equals negative 4/5. Sine is what? Y. Okay, so look on your unit circle, guys. Where are the y values negative 4/5? None. So what do? Cross it off. Perfect. So if you guys could just remember, we're trying to isolate our trig function. If there's more than one, I guarantee you can factor something. It's just going to be like basic solving of our equations. You have to remember that slide at the first beginning where sine is y, cosine is x, tangent's y over x. I think it's super important to memorize which tangent is root 3 over 3 and which is just root 3. Again, if you don't, it's not that big of a deal because you can mathematically figure it out, but it just saves a little time. But other than that, this is all, solving is much easier than proving and all that good stuff. Everybody good? Okay.